If we were to do a rough sketch in free space, and we pick the points 2 minus 5, we could put that about there. Then the point 4 minus 9, we go across 2 from there, and go down to minus 9, that's going to be 4 jumps down. So you can already see that the gradient going through these two lines is going to be quite steep, it's going to be negative. So it's plausible that it's a gradient of minus 2. You can see that for every one we're going across, we're going down 2. And that's essentially going to give us a gradient of minus 2. But we need to show this. And the best way of showing it is by going back to one of the basic formulas for a gradient. We can do up divided by across. This is kind of an informal way of thinking about this. More mathematically, it's change in y, delta, that's the triangle. That means change in over change in x. So essentially you get, pick one of your y values, so I'm going to pick minus 5, and I'm going to minus the other y value, which is minus 9. That works out the change in y. And then I do 2 minus 4. It doesn't matter which of these coordinates you pick first. You could do minus 9 minus minus 5 or 4 minus 2, as long as you pick the same set of coordinates each time. So for minus 5 and the 2, they belong to the same coordinate as point A. So minus 5 minus minus 9, that's a double negative, so it's going to be minus 5 plus 9. When you're dealing with this kind of problem, you can switch them. So minus 5 plus 9 is actually the same as 9 minus 5. This is much more friendly to think about. The answer is 4. And 2 minus 4, that's going to be minus 2. 4 divided by minus 2, that indeed does give you minus 2. And just to show that it works the other way as well, if I was to do minus 9 minus minus 5 over 4 minus 2, then minus 9 plus 5 is equal to minus 4. 4 minus 2 is 2. Minus 4 divided by 2 is also minus 2. So both ways we've shown that the gradient is minus 2. One thing I missed off here, which is quite important actually, and that's finishing off by just saying equals minus 2. Otherwise we haven't fully shown that. For part B, we could assume that it's a straight line. If we were to do a quick sketch, and we've got the 2 points down here already, that's point A and point B, and if we went to minus 301, that's well down here, and positive 601, it could line that line. It's plausible, but we need to show that. Now consider the properties of a straight line. It's got a constant gradient. The gradient just continues in that direction. If I had a gradient which is changing, then it's going to be a curved line. Or if I had a straight line and then suddenly it changed, that's not a straight line. So we want this gradient to continue. That's probably the easiest way of tackling this question. We've already got a gradient of minus 2. Now we just need to show that the gradient continues. So if we find a gradient between point A and C, so we can do 2 minus 301 over minus 5 minus 601. This one we can do the other way around again, so we can do minus 301 minus 2, and we can also do it from point B, because both of these points lie on this line. As long as it's involving point C, then that's fine. So going through this, 2 minus minus, that's a double negative, that becomes a positive. We get 2 plus 301, that's 303. And then minus 5 minus 601, we're getting more negative, so it's going to become minus 606. You can see that 303 is half of 606, because if we were to double this 3 would become a 6, this 0 would stay the same at 0, and then this 3 would become a 6. But it's going to be negative, because we've got a negative involved here. So this gradient is also going to be negative 2, so it must continue. Another way of doing this is to work out the equation of a line. So to work out the equation of a line here, we already have a gradient. That's quite useful. So we have y is equal to mx plus c, where m is the gradient. Y is equal to minus 2x plus c. To work out where it crosses the y-axis, we're not given the coordinate of that, so we have to rearrange this and make c the subject. So c is equal to y plus 2x. And now we can substitute the coordinates of one of the points we know is on the line. At the moment we don't know this is on the line, so we can't use those coordinates. Now 2 minus 5, let's pick those ones. So C is equal to y, that's minus 5, plus 2, lots of 2. And when we do bid mass, we do 2 times 2 first, that gives us 4. We're adding that on to minus 5, that's going to give us minus 1. So equal to minus 1. We've now got the equation which we're looking for, and that's that y is equal to minus 2x minus 1. If you wish to, you could just do a quick check. So if you were to do minus 2 times by 4, that does indeed give us minus 8, minus 1, that gives us minus 9. So that seems to be working. And we could check it for that one as well if we wanted to. But that's using up to valuable time. We haven't really got time to spend on a 2-mark question doing this level of checking. Okay, so we've got the equation. If point C lies on that line, this straight line, then the line must continue. It must lie on that line. So we can check it. We can see if it works. So we can set y equal to 601 minus 2 times x, which is minus 301. And then we minus 1 from that. So minus 2 times minus 301, that's double negative, so that becomes 2 times 301, which is 602. 602 minus 1 is indeed 601. So this doesn't break the equation, it works. If we picked any point which wasn't on the equation, it wouldn't satisfy it. If it didn't satisfy it, then we might get an unusual answer, like 601 is equal to 598, or something quite unusual which just can't work. Then it hasn't been satisfied. So this proves that it lies on the line.